Hello everyone! Have you ever wanted to know the chemistry behind cake baking? Well, here's your chance. In this presentation, you'll learn the chemistry of cake baking in an experiment that bakes 4 different cakes. Let's review some basic background information. When cake dough is heated in an oven, a chemical reaction occurs and new bonds are formed. As you bake a cake, you are producing an endothermic reaction that changes the gooey batter into fluffy cake. An endothermic reaction is a reaction that takes heat in. Cakes as we know them today were discovered in the 18th and 19th centuries when eggs and bicarbonates of soda replaced the lightness of yeast with less time and effort. The baking process can be broken down into 3 stages: expansion, setting, and browning. As the temperature of the batter rises, the gases in the air cells expand the stretchy gluten from the flour, then the chemical agents release carbon dioxide. Carbon dioxide and water vapor account for the majority of batter expansion, while thermal expansion accounts for the remainder. At about 175 degrees Fahrenheit, the batter adopts its shape as the egg proteins thicken and the starch absorbs water. The browning reactions enhance the flavor of the cake and take place on the dried surface. Now let's get cooking, shall we? The first step to baking a cake is acquiring all the ingredients and mixing them together in the right order. In order to make this experiment simpler, we half-size the recipe. For each of the 3 special cakes, we left out either baking powder, oil, or eggs, as you may recall from earlier. After mixing all the ingredients together, we poured the cake batter into the appropriate labeled slot in the tray and continued the process until all 4 labeled slots were filled. Then we put all the cakes in the oven to cook for 9 minutes at 350 degrees. Cake A, the one with no baking powder, looked abnormal in size and texture, but still tasted relatively fine. Cake B, the one with no eggs, looked the most deformed and uncake-like, but surprisingly tasted the best. The fluffy texture wasn't present, but it was sweet and tasted almost normal. Cake C, the one with no oil, looked better than the previous 2, but tasted the worst so far. Cake D, the one with all the ingredients, turned out the most normal looking, but tasted the most bland. Now let's look at why this has happened. Chemical reactions. Baking powder contains sodium bicarbonate, also known as baking soda, and a dry acid. When liquid is added to a baking recipe, these 2 ingredients react to form bubbles of carbon dioxide gas. Cake without baking powder did not rise as much as the normal cake because carbon dioxide was not produced in the chemical reaction. Now let's look at eggs. An emulsifier molecule has 2 parts: an electric charge that dissolves water, but not oil, which is called hydrophilic because it is water-loving. The other part of the molecule is a long hydrocarbon that will dissolve in oil, but not water, which is called hydrophobic because it is water-fearing. These 2 different properties allow the molecule to make a link between oil and water, in turn holding the cake together. Now let's look at oil. When flour and water are mixed, sheets of gluten are formed. Sheets stick together into larger and larger sheets, making the batter tough. However, when the oil is added, the hydrophobic amino acids in the gluten attach to the fat and are not available to form bonds with other gluten molecules. This prevents sheets of gluten, and as a consequence, the dough is softer. You know, if somebody asked you, what's the chemistry behind baking a cake, you can point to a couple things.